Hi, if you tuned into this video, I certainly appreciate it. Basically, this video is going to be for the up and rising new HVAC people, men and women that are just getting into the field, to try to help them understand a little bit more on the pressures and temperatures that exist. We're all inside of atmospheric pressure. Some are in a higher pressure than others. Let's say like in Denver, Colorado, the pressure there, it has lower temperatures and lower pressures. And here in Georgia, we're just above sea level, about 1,000 feet. And to give you an idea, to boil water here, it takes about 212 degrees. But in Denver, Colorado, it's like 203 degrees Fahrenheit. It boils, and the thing is that because the atmospheric pressure is not bearing down on the refrigerant or the water, the water will evaporate a lot quicker. So, some say that it takes a little bit longer for that water to boil, even though it's lower temperature. So with that set in mind, what I wanted to do is to kind of give you an idea. The pressure and temperature chart here, it kind of tells you where the ambient temperature is, that you're working out in the field, and they give you numbers here to try to help you understand when you put on your gauges where you should be or close to these numbers. That way you have a better understanding of what you need to do. Now, I know that the digital gauges, they kind of do the thinking for you. They tell you the superheat, and they tell you the subcooling, and they tell you the temperature, and they give you the numbers and pressures and temperatures. But that's not always correct, and the reason for that is because if the unit is dirty, let's say, you're going to have higher pressure and higher temperature. And with that said, you're going to have to know where you should be as far as the reading should be, as opposed to a compound gauge that has numbers to it, but it doesn't do the thinking for you. You got to kind of figure it out yourself. And so what I'm trying to do is just to help the men and women that are coming into the field, to give them a better understanding of how pressures and temperatures work. For example, let me bring the camera in a little bit closer here. For example, we have a water bottle here. It's just straight H2O, and in that bottle there's air that's forcing down or pushing down on this water. And so what happens is that with the pressure pushing down on here, this water literally is just kind of standing still. But if I go ahead and this, by the way, is a vacuum pump. And what I'm going to do for an example to give you an idea of how the pressures work according to the temperature and the thinner air is I'm going to put on that vacuum pump, and what's going to happen is that this vacuum pump is going to start sucking out all the air that's above this water, and the water literally is going to start boiling. Now, it's not going to be hot to the touch, okay? But it is going to boil, and that gives you an idea of how the refrigerant is inside of a line set. Okay, so I'm going to go ahead and turn this on just for an example to show you what I'm talking about. Oh, I guess it'd help if I plug it in, huh? So you'll see what I'm talking about. And you can see as the vacuum pump is sucking out all the air that's above here, there's no pressure on that water, so it literally what it's doing is bubbling up because it's in a vacuum basically is what's happening. Let me go ahead and turn this off. So what happens is that once I release it and I start putting the air back into this guy will stop bubbling. And there you go. You know, the other day, let me back up this camera again so I can talk with you. I don't know if that's right or wrong. But the other day, you know, I was putting in a compressor for a customer, and, you know, he came out and he heard the vacuum pump running, and he, you know, kind of basically wanted to know, hey, what's going on, you know? So I explained to him, well, what I'm doing is I'm vacuuming out the system, or the line set, as we call it, and, you know, trying to take all the contaminants out of the line set, any kind of, you know, air molecules that are in there, you know, boil them out as you're vacuuming and sucking out all the air. All of that is boiling, literally, just like what you saw here. And so what happens is that once we get that down to what they recommend is 500 microns, you know, or even lower, then that gives us an idea that, hey, we've got this thing down pretty low as far as any air or any contaminants in the system. And then that way, when we start putting in the refrigerant, because there's no air in there, that refrigerant will just, you know, we always put it in on the high side, or the small 3/8 line, and that refrigerant will literally flow in there and start filling up that suction line, and also the high pressure side, you know. Changes a little bit from liquid, and once it hits the TXV of the piston, then, you know, it's like what they say, 80-20%, 80% liquid, 20% gas, and then that kind of goes around to the other side, and then that way, once those numbers equalize, you know, then you know that, you know, it's not going to take out or take in any more of the refrigerant, and then that's when you want to start using your, you know, your compound gauge or your digital gauge to find out exactly, you know, where you're at, and according to the nameplate, and that's going to help you figure out, well, where should I be with my pressures and temperatures. So, you know, with that said, I hope that gives you a little bit better understanding of how the temperature and the pressures have a correlation between both of them, and that's what refrigeration is all about. So hopefully, you know, if you have any comments, or if you like it, the video, and, you know, if you'd like to see some more, maybe you have a question that you may want to ask, we'll post it and put it on the comments, and I'll do my level best to try to get an answer back to you. But till then, I appreciate your watching, and thank you so much.